So today we're going to discuss what it means for something to be a function. And so before we begin, let's just get a couple definitions. The first one is that a function is a rule which assigns exactly one input to exactly one output value. The domain of a function is all of the possible inputs for that function, and the range of the function is all the possible outputs for that function. So when we're talking about functions, we have what's called a rule of 4, and that is that any particular function can be represented in one of 4 ways. It could be represented with a formula, with a table, a graph, or by words. So what we're going to do is look at an example, and we're going to see how all of these specific definitions apply. So here's our example. Here's our example. It says crickets chirp at the same rate if they are at the same temperature, depending on the temperature in degrees Fahrenheit. We can determine how many chirps a cricket will perform each minute. Okay, so if we discussed previously that the domain is all the possible input values, and what we're getting out is the number of chirps, then in this situation the domain is the temperature. The output, or the range, what we're getting out of this function is the number of chirps. And so let's say for this particular function, the chirps is a function of the temperature, which is equal to 4t minus 160. So C of 55. Notice that 55 is in place of t in our original function. Then C of 55 is equal to 4 times 55 minus 160. And so C of 55 equals 220 minus 160. Or we'd say C of 55 equals 60. So let's think back to our input and our output. If we're asked to interpret what C of 55 means, 55 is in place of t and 60 is our output. So what this statement is saying is the temperature of 55 degrees Fahrenheit will produce 60 chirps per minute. So now that we've got our formula, we're going to look at how you might represent this with the table. So notice for this particular table that the input is the top line and the output, C of t, is the bottom line. And typically that's how you'll see it. Sometimes you'll see them written more vertically, where the left column would be the inputs and the output would be the right column. So for this particular table, why do you think we start at t equals 40, or the first input is 40? Well, you notice that the output at 40 is 0. So that means the crickets will not even begin chirping till we reach at least a temperature greater than 40. So why would we start at t equals 40? Well, there are no chirps when t is less than or equal to 40. So if we wanted to compute a specific number of chirps with a temperature, so like I'm saying here to compute C of 60, what this is saying is what is the number of chirps when the temperature is 60. And you'll notice here when T is 60, C of 60 is 80. So what we're saying here is that when the temperature reaches 60 degrees, you will have 80 chirps per minute. So we now have our formula, our table, and here's an example of what the graph would look like. For any graph of a function, we're typically going to make the horizontal axis our input, or represent our domain values. And the vertical axis will represent our output values. So here, if we want to estimate C of 100, what we are saying is, what is the number of chirps when the input is 100? So what we want to do is look at when the input is 100, which occurs right here. What value or what output value corresponds to that? To me, it looks like at 100 degrees, we are getting about somewhere between 200 and 300 chirps, or I'm going to estimate that at about 240 chirps per minute. So the last way we want to represent a function is somehow to state what it is in words. So looking at our function, hopefully what you've noticed so far is that the chirps is determined by temperature. So here, if I was going to represent this function in words, I would say the chirps per minute is equal to the temperature multiplied by 4 and then subtracted by 160. That is to say that we could input any temperature, and what we would do is multiply it by 4 and subtract 160. So that's another way that we could possibly represent this function. The last critical part of functions that we want to discuss are the intercepts, meaning the vertical and the horizontal intercept. The vertical intercept, or where we would intersect with that output axis, occurs whenever the input is equal to 0. That is to say, the vertical intercept is equivalent to when we plug in 0 to the original function. So if we wanted to interpret C of 0, well, let's first figure out what that would equal to. So notice 0 is in place of t. So 4 times 0 minus 160. In other words, we get C of 0 equals negative 160. So what we did is input 0. And our input in this case is temperature, and our output is chirps. So in this case, if the temperature was 0 degrees Fahrenheit, you would have negative 160 chirps per minute. And obviously that can't happen. If you think back to our table example, we didn't even include the value of 0 degrees, and that's because the crickets wouldn't even begin chirping at that moment. The horizontal intercept occurs when the output value is equal to 0. That is to say, when this function itself equals 0. So if you'll notice, what we would do if we wanted to find the horizontal intercept is we would take the function and set it equal to 0. So in this case, we could actually figure this out and solve this for t. So we'd add 160 to each side. So 4t would equal 160. And if we divide by 4, then t equals 40. So what this is saying is it's basically figuring out when would the chirps equal 0. And as we previously discussed, when the temperature equals 40 degrees, you get 0 chirps. So interpret C of t equals 0. At 40 degrees Fahrenheit, there are no chirps. In other words, as soon as we reach a temperature greater than 40 degrees, the crickets will begin chirping.